Today I'm going to talk about nuclear weapons and about the challenge nuclear weapons pose for humanity. I'm going to present this lecture in historical terms because I think that's the best way to understand the problem. The problem is basically the problem of control. The invention of the atom bomb was difficult, but controlling it has proved to be even more difficult, in fact, impossible. This has led to an unprecedented effect of science on history. You can't now understand history without reference to this impact. It started with the Manhattan Project. This is the invention of big science, the science that, by drawing together large numbers of researchers and lots of material resources, has huge social impacts. But in the beginning, it was just two guys, Szilard and Einstein, two obscure, at least Szilard was a rather obscure physicist. Einstein was well known, and this is why Szilard went to Einstein and told him that it would be necessary to contact Roosevelt and explain to him that the Germans might get the atom bomb first and win World War II unless the U.S. started a bomb project. This was a reasonable worry since German science at the time was outstanding. It was the best in the world. Well, Roosevelt was impressed by the letter and ordered the creation of a lab for the building of an atom bomb in Los Alamos, New Mexico. And Robert Oppenheimer, a physicist who had been educated in Germany, was appointed to direct the lab. And we know the rest of the story. The bomb was successfully created, and it was used to end the war with Japan. And that, of course, set off the arms race, which is still ongoing. Here's a picture of Einstein and Oppenheimer, the man who was given the direction of the Los Alamos laboratory. Well, after the bomb was actually successfully tested in the deserts of New Mexico, some of the physicists who had made it opposed dropping it. They argued that the original rationale was to beat Germany in the race for the nuclear weapon, but Germany was already defeated. Why drop the bomb on Japan, which hadn't been part of the original rationale for creating the bomb in the first place? The physicists who worried about dropping the bomb on Japan had essentially two arguments. One was that it would produce civilian casualties on a huge, unprecedented scale. It would transform war, which had already begun to become an assault on civilians because of the industrial basis of military power, into an outright genocide. And the second reason for opposing the dropping of the bomb was the arms race that they anticipated would begin. And they had good reason to worry. The military people and the politicians didn't think anyone else could do what Americans had done. But these physicists, many of whom were educated in Germany, had met good scientists, good young people from Russia, and knew that those guys would be able to do whatever we could do. So what did they propose then? Well, they thought perhaps a demonstration of the power of the bomb would dissuade the Japanese from continuing the war. I want to say a little more about Szilard, because he was the most prescient of them all. Remember, he's the guy who got Einstein to write the letter to Roosevelt. He's a Hungarian physicist who was born at the end of the 19th century. He was brilliant. Among other things, he patented the nuclear reactor design, the first nuclear reactor design that was eventually used to make electricity. We still have nuclear reactors, although I think probably they've evolved since the 1940s. Szilard was a pacifist, but somehow he managed to start the arms race. It's the paradox and the irony of history. He opened Pandora's box. You know the story. When the box was opened, all the ills of mankind came out. Pandora was curious. She wanted to see what was in there. And unfortunately, she went ahead and opened the box with disastrous results. Another metaphor to what Szilard started is the sorcerer's apprentice. Remember that story. The sorcerer's apprentice is given the task of sweeping out the premises when the sorcerer is away, and he uses a spell that he's overheard to cause the broom to multiply and to do the sweeping for him, and it gets completely out of control. And this is exactly what happens with nuclear weapons. Well, Szilard anticipated these problems and tried to stop the development of nuclear weapons long before they were actually feasible. His first attempt was to patent them, and he gave the patent to the British Navy. This was, of course, silly, because no nation would permit itself to be blocked in wartime from using ideas just because they were patented. But it was at least an attempt. His next attempt during wartime was to get scientists to stop publishing on nuclear fission. Fission is the process that makes the bomb possible. And if you could just get the scientists to shut up, maybe no one would come up with a weapon before the end of the war. And then it would be it'd be easier to work out some sort of scheme for preventing the weapons from ever being produced. There were only 3 labs in the world that were at the top of this study, at least outside of Germany. And those labs, 2 of the labs accepted the proposition and decided not to publish. But the 3rd lab, the one in France, refused, and so the publication then continued. And that made it possible to develop the bomb quite quickly. The last attempt was a petition. This was a petition to the president asking him not to use the bomb. And that also, as we'll see, was unsuccessful. After the war, Szilard wrote a book of science fiction stories called The Voice of the Dolphins. And it reflects his bitter experience trying to affect the world through political appeals and appeals to scientists. The dolphins are housed at an institute in Vienna, and a group of scientists teach them how to speak and learn from them all sorts of wonderful things. And then those scientists gradually get old and they leave, and a new, younger generation of scientists comes in, but they can't seem to communicate with the dolphins. And the idea is that the dolphins are really that first group of scientists who know all the solutions to the world's problems, but no one will listen to mere scientists unless the word comes from dolphins, from some strange place. The solutions will be ignored. So here's the petition. This is the actual thing. I extracted a portion of it. The second part, you can see it says a petition to the President of the United States. And the second part says the added material strength which the bomb gives to the United States brings with it the obligation of restraint. And if we were to violate this obligation, our moral position would be weakened in the eyes of the world and in our own eyes. It would then be more difficult for us to live up to our responsibility of bringing the unloosened forces of destruction under control. And at the bottom you can see the signatures. The third one is Wigner, a Nobel Prize-winning physicist. Szilard also worked with another physicist named Frank. They issued a report that was supposed to make the same point. And here's the principal paragraph from that report. If we consider international agreement on total prevention of nuclear warfare as the paramount objective and believe it can be achieved, this kind of introduction of atomic weapons to the world, that is to say, dropping it on Japan, may easily destroy all our chances of success. Russia and even allied countries, which bear less mistrust of our ways and intentions, as well as neutral countries, will be deeply shocked. It will be very difficult to persuade the world that a nation which was capable of secretly preparing and suddenly releasing a weapon as indiscriminate as the rocket bomb and 1,000 times more destructive is to be trusted in its proclaimed desire of having such weapons abolished by international agreement. So Frank didn't have any more luck than Szilard. Government officials and military officials were in favor of dropping the bomb. They wanted to end the war as fast as possible with the fewest American casualties. They also felt the need to end the war quickly to deal with the huge refugee crisis in Europe, where the war had just ended and where millions of people were on the move. They saw the bomb as actually a psychological weapon, a terror weapon. The idea was to intimidate Japan into surrendering. Actually, I think they only had 2 weapons at the time, but they pretended they had more and that they could essentially exterminate the Japanese population with them. And this worked. They didn't believe a demonstration would be convincing. But blowing up tens of thousands of people and whole cities, that they were convinced would cause the Japanese to surrender. And in fact, it did. This is what Nagasaki looked like after the explosion. Well, the scientists didn't give up. Even though they had prevented the dropping of the bomb, they were determined to work for disarmament. Oppenheimer, the head of the lab that created the weapons, was one of the principal advocates for negotiating a treaty with the Russians to prevent the spread of nuclear weapons. But there was a problem. The scientists believed that nuclear energy would be very important in the future. So they were dealing with a dual-use technology. On the one hand, you could blow things up. On the other hand, you could power the world. So you couldn't just say, let's abolish all research and all development in the field of nuclear physics. Oppenheimer worked with people in the government to develop a disarmament proposal called the Baruch Plan. The idea was that the Russians and the Americans would agree to mutual inspections and thereby overcome their distrust and pledge to not develop nuclear weapons. And this Oppenheimer associated with the idea that eventually a world government would be necessary to prevent war now that war had become so dangerous. He wrote in one paper, he says, "Many have said that without world government there could be no permanent peace, and without peace there would be atomic warfare. I think one must agree with this." But the problem of suspicion between the Russians and Americans and the unacceptability of inspections to the Russians, who after all had just been invaded, lost about 10% of their population in war with Germany, and then the question of the veto in the United Nations, which would allow the Russians to prevent any action by the UN in the event of disagreements. All this led to the collapse of the effort at disarmament. Many scientists were persuaded that this was a crisis and that they had to work for disarmament somehow, even though there were all these obstacles that were revealed by the failure of the Baruch Plan. Something called the scientist movement developed, an actual movement of scientists, most of them physicists, who had either been involved in the creation of the bomb or who were well aware of its implications and dangers. These were scientists acting as citizens. They hoped to influence opinion because they alone knew what the score was. But there are quickly other problems. The military wanted to control all nuclear research, and the scientists were unhappy with that. They didn't want to be subjected to high levels of secrecy and very punitive control systems, security systems. And so they fought, the scientist movement fought not just for disarmament, but also for civilian control of nuclear research. And out of that came the grant system, which we still have in universities in the developed world, where government grants are given to scientists through the university system rather than through the military. Well, the call for disarmament was unsuccessful, but it did eventually lead to various treaties, to an end to above-ground testing, which caused nuclear fallout all over, radioactive isotopes in the milk of children throughout the Midwest of the United States, and other problems in the Pacific, where people were exposed to testing. So above-ground testing was effectively ended. The number of weapons reduced somewhat. There was a great hope in the UN, but in fact it was not able to do much more than ratify what the Russians and Americans agreed to. And in the end, these treaties simply normalized what came to be called MAD, mutually assured destruction. I wanted to show you this. The scientist movement developed a journal, still exists, called the Bulletin of the Atomic Scientists, and on its cover there was a clock. Here's the clock, and you can see the hour hand is at midnight, the midnight of nuclear self-destruction, and the minute hand is a few minutes ahead of midnight. It's been there with slight movement back and forth ever since the bulletin was first created. Well, there's another interesting sidelight on the problems of the scientists as in their attempts to influence the development of the arms race. Oppenheimer, as I told you, was appointed head of the Los Alamos laboratory. He was a brilliant organizer and synthesizer. Everyone admired his abilities. But he was also a leftist. After the war, he became a top advisor to the United States government. This didn't seem as big a problem when Truman was president, but eventually, under Eisenhower, McCarthyism became a kind of, it's hard to explain, a sort of panic, moral panic. Everyone in the U.S. was supposed to be afraid of communists infiltrating everywhere. And Senator McCarthy managed to mobilize opinion on a huge scale. And this eventually caused Oppenheimer's leftist past to catch up with him. And the main problem was something called the General Advisory Committee report on the creation of the hydrogen bomb. So this is in the early 1950s. The atom bomb is a powerful weapon, but the hydrogen bomb is potentially 1,000 times as powerful. You can make them as big as you want. So instead of just destroying the city center, you can destroy a whole region with hydrogen bombs. And enough of them lobbed at the same time would essentially make human life on Earth impossible. This worried the people, the scientists on the General Advisory Committee that was advising the United States government on its actions in the arms race. And so when they were asked what to do about the possibility of building a hydrogen bomb, they objected. They said, no, it's not a good idea. Oppenheimer agreed with this view, and it was most cogently expressed in an appendix to the report by two other physicists Fermi and Rabi. And this is what they wrote. The fact that no limits exist to the destructiveness of this weapon makes its very existence and the knowledge of its construction a danger to humanity as a whole. It is necessarily an evil thing, considered in any light. Well, Oppenheimer's reluctance to endorse the creation of the hydrogen bomb raised questions of loyalty in the McCarthy era, and politics now mixed in with science in a fatal way that resulted in him being kicked out of the government. So what did we end up with? Well, it's called the balance of terror, mutually assured destruction. It's a system based on deterrence. And deterrence is a peculiar kind of game theoretic logic that works like this. What they think we will do determines what they will do, and vice versa. So if the Russians think we are going to try and bomb them, then they will do what it takes to keep themselves from being bombed. And if we think the Russians might bomb us, we will also do the same things that we need to discourage them from bombing us. And so each side feels it needs more and more weapons so that if it's attacked, it can fight back. And this then became the military doctrine called massive retaliation. The idea is that if they attack us, we will annihilate them. And this then raised all kinds of problems in strategy. For example, the key problem is the first strike problem. Suppose they attack us and use some of their weapons to destroy our nuclear weapons. Then we are helpless. So we need what is called a counterforce strategy. That is to say, a way of ensuring that enough of our weapons would survive a first strike so that we can destroy them. In that case, they'd be scared to do a first strike and there wouldn't be a war. So this is why the United States has nuclear submarines parading around the world with the ability to launch nuclear weapons. And the Russians actually put some of their missiles on trains riding around in the countryside, so that it would be impossible to catch all their weapons at the same time. Well, all kinds of dangers result from this situation. There was, for example, the paradox of the Star Wars initiative under Ronald Reagan. His idea was, we'll create automated battle stations in space on satellites able to shoot down missiles, incoming missiles, before they can land. This sounds good. There couldn't be a nuclear war if the missiles would all get shot down. However, there's a problem here. The first nation to get the Star Wars defense system would be immune to attack. It would not have to worry about a counterforce attack. And so it would be tempted to engage in a first strike. Now, of course, we know the United States would not do such a terrible thing. But remember, what they think we will do determines what they will do, and vice versa. So if the Russians think that we're prepared to launch a first strike, because now we're immune to their counterforce, then they will have to launch a first strike before we can deploy Star Wars. So the whole thing, the whole idea of making it impossible to fight a nuclear war could actually cause a nuclear war. Then there's also the problem of accidental war. There's a famous movie, which you should see if you haven't, called Dr. Strangelove, about how an accidental war could actually get started. Another problem that was pointed out in the 1970s, I think, is the problem of nuclear winter. By then there were enough nuclear weapons, so if they were all launched, it would create a huge dust cloud in the atmosphere and cool down the planet. Not just cool it down, but freeze it. There'd be another ice age. That would be the end of humanity. And then finally, there was by far the worst problem of all, the problem of proliferation. Here's a shot from Dr. Strangelove. This guy was trying to get the bomb loose because the bay wouldn't open, ended up sitting on it as it fell out of the plane. And here he is waving his cowboy hat as he falls to nuclear planetary nuclear destruction. So proliferation is the biggest problem. Szilard and Frank were right. If you once start this process, you cannot stop it. The scientists warned that the secret couldn't be kept. At first, the US and Britain were the only countries that knew how to make a bomb, but in 1949, the Russians tested one. Why? Because they were scared of the US. The French then were afraid that the US would abandon them in the event of a Russian invasion of Europe, so they got a bomb. Then the Chinese got a bomb to defend against the US. India got one to defend against China. Pakistan to defend against India. Israel to defend against the Arabs. You can see where this is going, etc. The nth country is the one which not only gets the bomb, but uses it to start a nuclear war. Well, in order to prevent the nth country from ending up with a bomb, the nuclear powers initiated the Non-Proliferation Treaty. And this is the treaty under which most countries in the world have agreed not to develop nuclear weapons. However, by now it's really too late. A few countries, India and North Korea, for example, violated the provisions or refused to join, and nevertheless, in the case of India, have been accepted into the nuclear club. And I think the same will happen with North Korea. And then there may be other countries too. Pakistan also, I think, violated the provisions and yet is now considered okay. So we're coming to the end of this. Very brief summary of many of the themes of the study of history of nuclear weapons. I want to mention here a comment by the French historian Foucault. Foucault wrote that Oppenheimer represented a new type of intellectual, which he called a specific intellectual. These are intellectuals who intervene in politics on the basis of their specialized knowledge. In other words, they act as citizens, but out of their place as scholars or scientists. Foucault distinguishes this from what he called the universal intellectual of the past, someone like Voltaire or Sartre, intellectuals who act on the basis of a philosophical stance without any specialized technical knowledge. But in the world today, we need specific intellectuals too. And we can see that because of the relevance of this type of intellectual to some of our most important concerns. And I can mention three here, which we'll talk about. Environmental concerns, which depend on a knowledge of biology. Climate change, which depends on many types of knowledge of planetary science. And computer science, which is involved in the problems we have now with the internet. So if we follow Foucault's line, then we can see Oppenheimer as the beginning of a new thing in the world of politics, the intellectual as political actor on the basis of specialized knowledge.